Hello doctor, today I will discuss on how to derive the state space representation from electrical system. For this circuit there are three state variables. These state variables are the current flowing through the inductor IL and the voltage across capacitor Vc1 and Vc2. From the circuit the output voltage is equals to the voltage across capacitor Vc2. To find the capacitor's differential voltage, we must find the current through the capacitor. This is due to the formula which is CVD Vc over T equals to IC1 C2 dVc2 over dt IC2 and LdIL over dt over VL. Therefore, to find the current at a capacitor, we will be using nodal analysis to obtain the equation. In this case, IC1 is considered as the total current and IL and IC2 is considered as a branch current. So the equation will be IC1 equals to IL plus IR and IC2. So we can derive as a IC plus VT minus VC1 and VC2 over R. So we need to transfer to the differential voltage capacitor 1. So the last equation will be 1 over C1 IL plus V of T 1 over R times C1 minus 1 over R times C1 Vc1 minus 1 over R1 RC1 Vc2, and then we have to substitute the value. Then we obtain IL plus V of T minus Vc1 minus Vc2. Then to find the inductor's differential current, we must find the voltage through the inductor. To find voltage across inductor, we will be using KVL method. So we will obtain V of T minus Vc1, and then we will transfer the L into the equation and we will obtain 1 over L V of T minus 1 over L Vc1. After that we will transfer the value into the equation and we finally obtain V of T minus Vc1. To find the second capacitor differential, the process is same as the first capacitor differential voltage. Thus, final equation of this capacitor is 1 over RC2 V of T minus 1 over RC2 Vc1 minus 1 over RC2 Vc2, and then we have to substitute the value and then we obtain V of T minus Vc1 minus Vc2. After obtaining these three equations, it will transfer to the matrix form. Then the obtained value will transfer to the MATLAB to view the step response. This is the matrix form of state space representation. First is the input and the second is output. Calculation: there is a long process to transform state space representation to transfer function. First and foremost, identify the state variables A, B, C and D. Then find the value of Si minus A, and then find the value of inverse SIA. So to find the inverse, we have to find the determined value, then the transpose value, and then we find the inverse is equals to adjacent over Si minus A over determinant Si minus A. And finally substitute Si minus A minus 1 B, C and D into transfer function matrix. The final answer from this calculation are exactly same as the final answer from the MATLAB.
Hello doctor, I'm Shashi from group 6. Today I would like to explain about part A, state space representation, which was carried out in MATLAB software. First of all, we have to declare the values of capacitors, inductor and also resistor. So according to the figure 1, all the values were 1. Next up is the matrix A, which was obtained from the calculated values just now explained by my fellow groupmate Arvind, and matrix B, and also matrix C and D. So as we can see here the last one is EIGA, uh, which represents the eigenvectors and also eigenvalues of matrix A. Once we're done with the coding, now let's click the run button. After clicking the run button, here we can see C1 equals to 1, C2 equals to 1, L equals to 1, and R equals to 1, which were declared initially in the MATLAB coding. And we can get the A matrix values, which is negative 1, 1, negative 1, negative 1, 0, 0, negative 1, 0, and negative 1. And matrix B will be 1, 1, 1, matrix C is 0, 0, 1, and finally matrix D will be 0. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Shami Al-Ghani. Now, I will be part B. We need to transfer the state space representation into transfer functions. So, transfer the state space representation into transfer function, we will be using the Simulink. So, we will need this block, step block, gain, header, another gain, A gain, integrator, C gain, and then scope. So we set the stop time at 50 seconds. So if we run this, so we double click the scope so we can see the graph for these transfer functions based on the state space representations. So this is by using Simulink. So another way to represent it, we can use MATLAB coding. So for the MATLAB coding, we can use this. We can use this. We can use this command. So num10 ss2 tf abcd, and then the command gtf, numerator and denominator, and then we use the step g. So if we run this, we will get this. So if we are comparing this step response graph with the Simulink graph, we basically get the same. The initial value is a bit different because in Simulink we set the step gain to 1 to 1. But for the MATLAB, we set the initial value for the step gain is 0. So, but another character, but all of the other characteristic is basically the same. So I think that's all for me. Thank you.